Hello ladies and gentle ladies, and welcome back to another Minecraft modding tutorial for Fabric 1.21, and in this tutorial we are going to be doing OreGen. So let's go ahead and get started. So the first thing I will say is that this tutorial will require the previous tutorial, as we are going to be using datagen for our ore generation. Now it is possible to do ore generation without datagen, however it is a bit more of a pain since you have to obviously manually write all the JSONs. So if you do want to do that, and I highly don't recommend it, but if you do want to do that, then my GitHub will be linked in the description, and you can just go into the generated package and you'll be able to find the generated JSON files in there. But since we are going to be using datagen, it will be so much easier. It'll be hundreds of times easier. So that's what we're going to use. So the first thing we're going to do is inside of our init package, we're going to create a new package, and this will be called worldgen. And then inside of here, I'm going to create a new class, which will be our configured feature init. So inside of here, we're going to create some registry keys. So we'll go public static final registry key of type configured feature, and this will take in 2 wildcard parameters there, and this will be the overworld test or key, and this will just be equal to register key, which is going to take in overworld test or that is register key, not register. There you go. And before we continue, let's create this register key method. So this will be a private static registry key of type configured feature, like that, and we will call this register key. That will take in a string name, and inside of here we're going to return registry key dot of. That will take in registry keys dot configured feature, and then we will use our method from our main class to create the identifier. So that will be tutorialmod.id, which will take in the name, like that. Then we can continue for the never and the end as well. So we can go the same thing again, registry key. In fact, I'm just going to copy paste this like that, and we'll go never for this one, and then end for this one. Obviously make sure you change these keys in here as well. And this is not a test OR. I don't know why I called it that. This is an example OR. Okay, now once we can do that, we actually have to create our register method that will be used for our datagen. So we're going to go with a private static. Now this method will be generic. So we're first going to have FC, and FC will extend feature config. So when we're referring to FC, that will be the feature config. Then we're going to have F, which is going to extend feature, and make sure you're importing the right feature here. So that is from net.minecraft.world.gen.feature.feature, and that will actually take in the feature config like that. This method will be void, so we don't need to return anything, and this will just be called register. Now inside of the parameters, we're going to have 3 different parameters. So we're first going to have a registerable, which will take in a configured feature, and this will be the context. So think of that like the context that we're going to be using. Then we're going to have the actual registry key that we want to register. So this will take in a configured feature, and my bad, there's actually going to be 4 different parameters. So I almost forgot one. So we're also going to want the actual feature itself. So that will be F. So we're going to say F feature, and then we're going to say FC, which is the feature config. Okay, now what we're going to do in here is we're just going to call context.register. We're going to pass in the key, and we're going to create a new configured feature. So a new configured feature, and this will just take in the feature and then the feature config. Okay, like that. Now, also to simplify this even further, what I'm going to do is I am going to, actually no, we'll leave it like that. I don't want to make it too complicated for the future. So then we need to actually create a method that we can call to essentially assign these keys to a specific configured feature. So generally, at least what Minecraft calls this themselves is they call this the bootstrap method. So I think let's just call it the same thing to keep it consistent with Mojang. So we're going to go public static void, or I say it's Mojang, it's probably not Mojang, it's probably Yarn calling it that, but either way we'll try and keep it consistent. So this will just be called bootstrap, and then we pass in a registerable, which once again is going to be the context, so registerable of configured feature like that, and this is the context. Now for this we need to create some rule tests, and these rule tests will effectively define where our block should be. So for example, for your ore you may have a stone variant and a deep slate variant. So you want the stone variants to only replace stone, and you want the deep slate variants to only replace deep slate. So for that we create rule tests that define effectively what the rules are for what it should replace. So we'll create the stone one first, and actually whilst I'm at it, one thing I didn't mention is I've obviously already created all the blocks. So I've obviously created an overworld one, which is just the default one, then deep slate, and then never, and then end. So those are just basic blocks there. So in the bootstrap we can create our rule test. So we'll start with stone, so we're going to go rule test, and we'll call this stone or replaceables, which is going to be equal to a new tag match rule test, since we're going to be matching a specific tag, and that will be block tags dot stone or replaceables. Then we're going to create another rule test, so we're going to go rule test. This will be the deep slate, so we'll go deep slate or replaceables, which is once again going to be a new tag match rule test, which will be block tags dot deep slate or replaceables. Then we're going to create another one, which will be for the never, so we'll go never or replaceables, and that will be once again a tag match rule test, which will be block tags, and this time it is base stone never. Then we're going to create one for the end, and this one will be slightly different, so we'll go end or replaceables. This is going to be a block match rule test, since in the end there's basically only end stone, so it doesn't make sense for there to be a tag. So we're just going to do a block match for blocks.endstone. So you can imagine how this would work if you wanted it to be in something else other than stone, so like gravel or whatever. You would just do a block match rule test for like blocks.gravel, and effectively that would be a match for gravel, but obviously we don't want that for ours. Then what we need to do is create the targets. So effectively, if it hits the stone or replaceables, then what should it replace it with? So for that, we're going to go a list of or feature config dot target, which will be the overworld example targets, which will equal list dot of. In here we can do or feature config dot create target. We can pass in our replaceables, so stone or replaceables, and then block init dot example overworld or, and we need to get the default state from that. Then we can do the same thing for the deep slate, so we can go or feature config dot create target. We can go deep slate or replaceables, and then block init dot deep slate or, like that. Once again, get the default state. Then we need to do the exact same thing for the never and the end. Then all we need to do is go ahead and register that. So we're going to call the register method. We're going to pass in our context. Then we're going to pass in the key. So we're just going to do the overworld key. Then we'll do feature.or. So that's going to be the specific feature we want to use. You see there is also a scattered or feature if you wanted to use that one. But we're just going to use the or. Then we're going to go a new or feature config, and that will take in the targets first of all. So we'll do overworld example targets, and then we pass in the size of the vein. I'm just going to say 9, and then you can optionally pass in a float, which is whether or not it should discard on air. So that will be the chance that it discards. So for example, if you say 0.5, then effectively if it reaches air, there is a 50% chance it just won't generate there. So effectively that's how that works. I'm not going to pass that parameter in because I want to be able to find our ore much easier. One thing I would recommend whilst you are testing to see if it works is having this number be a bit higher than what you actually want it to be, so you can find it much easier. Then we're going to do the other ones as well, and I'm just going to keep the sizes the same for all of them. So the vein size will just be 9 for all of them, since that keeps it nice and simple, but obviously you can mess around with that how you want. Once we have done that, we can do the placed feature. So configured features are effectively a feature with a specific config applied to them. A placed feature is the more so a actual feature that is placed in the world. So we'll do a placed feature init. This is going to be pretty similar. So we'll start off with creating the register key method again. So we'll go private static registry key. This will be of type placed feature, and I'm going to call this register key, which will take in a string name. So this will return registry key dot of, then that will take in registry keys dot placed feature, and then that's going to use our method from our main class again, which will be tutorial mod dot id, which will take in the name. So that will register us a key. Then we're going to create the actual register method as well. So let's do that now. So we'll do private static void, and this will be called register. This will take in the context again, so that is a registerable of placed feature as the context. Then it is going to take in a registry key of placed feature, which is the key. Then it's going to take in a registry entry of configured feature, which will be the actual config, or it's the configured feature, but config, easy. And then we'll do a list of placement modifier, which will be the modifiers. So what we're going to do in here is context.register. We're going to pass in the key. Then we're going to do a new placed feature, which will take in the config. And then we're going to do list, and we're going to actually create a copy of this list just so it can't accidentally be modified. And boom, that will be our register method. Now there is one more thing we're going to do, and that is to actually create these modifiers. So unfortunately, these are private in vanilla, which is really annoying actually. So we're actually going to have to create these methods ourselves. So what we can actually do is we can just go ahead and copy these straight from vanilla. So we can go into the ore placed features class, and you do need to make sure you include non-project items. There you go. And if we scroll down in here, you can find these modifier methods. So I'm just going to copy paste these, and I'm actually going to create a subclass. I'm going to go a public static class. I'm going to call this modifiers so that we keep it at least a little bit separate from this class. And I'm just going to paste these in here. And we are going to want to import these things. Now, when you paste it in there, just make sure that you do remove, because when you paste it, if you paste it just normally, it would do like or placed features dot modifiers. So that obviously wouldn't work. So you need to make sure you just remove that if you did do that. I just pasted as plain text, which is Control-Shift-V instead of Control-V. So you can do that as well if you want. And these are private by default, but we can make these public so that we can use them anywhere we want. So we'll just do that. There we go. Now we can actually register the placed feature. But first we need to create the keys as well. So this will be exactly the same as our configured feature. So I'm going to copy them. I'm going to paste them in here, and I'm actually just going to do a quick find replace here. So I'm going to find replace on the registry key of configured feature, and I'm just going to replace that with registry key of placed feature. And if I replace all, that'll replace these three, so then they are exactly the same. Now one common thing I do see some people do is they like to name these slightly different to their configured features, so they might add underscore placed afterwards. I personally don't get the point of doing that, since they are going to be in separate folders when we actually generate them. So I'm just going to leave them to be exactly the same name so we can easily match them up, and it's much easier to tell if there's an error. We can just see, are they all the exact same name? If they're not, then that's probably the error. So I just prefer to leave them the exact same name, so it's easier to debug if anything goes wrong. Then we need to create this bootstrap method again. So we're going to go public static void bootstrap. It's going to take in the registerable of placed feature, which is once again our context. Now inside of here we need to create an actual registry lookup, which will be used to look up our configured feature that we registered. So let's do that first of all. So we're going to go registry entry lookup of type configured feature, and I'm going to call this the registry lookup, and I'm just going to set this equal to context dot get registry lookup, and we're going to say registry keys dot configured feature, like that. Nice and simple. Then we can call the register method. We are going to once again pass in the context. Then we're going to pass in the key that we want to use. So we're going to use the overworld one first. Then we are going to use our registry lookup to get that configured feature as an entry. So we're going to say registry lookup, and we're going to use get or throw. So if it will get it, but if it can't get it, then it will throw an exception. So it will get or throw, and we're going to use configured feature init dot, and we're going to select the overworld one. And then after that, we need to provide our modifiers. So we're going to do modifiers dot modifiers, and we can use with count here. So you can use with count or with rarity, or you can just provide a specific one for the count modifier. I'm going to use with count here, and I'm going to say that there will be 9 again, just to keep it simple. So there will be about 9 per chunk is what this means. Then we need to provide it with a placement modifier for the height. So this will say effectively what is going to be the height range for this placed feature. So to do this, we say height range placement modifier. We are going to use uniform for these, so that means it will just be uniformly distributed, but you can also choose to use trapezoid, which I believe means that there will be more in the middle, I believe is what that means, but I'm just going to use uniform. And in here we need to provide 2 different Y offsets. So Y offsets are actually a little bit complicated, so I'll show you the simple one first, and then I'll show you the more complex ones. So you have Y offset, and you can just use a fixed Y value. So for example, say we wanted it to generate from 0, you would just use Y offset.fixed 0. And that would always be the 0 height. However, maybe you wanted to use the bottom of the world. Now, in 1.21, and just more recent versions really, the bottom of the world is obviously not 0 anymore, it's now -64. But what if it wasn't -64? Because that could be changed by a data pack or something. So maybe you always want it to be the bottom of the world no matter what, and so you could use the bottom, like that. However, maybe you wanted it to be some value above the bottom, in which case you could use above bottom, like that. Maybe you wanted it to be somewhere below the top, then you could use below top, or if you wanted it to be the top, then you would use top, like that. So that's basically how these all work. Fixed just means it doesn't matter what the height of the world is, it will always be at this specific fixed height. So that's what I'm going to use. I'm just going to say it will be fixed at -24 is just what I'm going to use. And then we need the max height as well, which I'm going to use fixed again. And I'm going to say a fixed height of 64. And we're going to make sure we close off these brackets. So I think that's those ones, like that. And then we can do the exact same thing for the end and for the never as well. Boom, like that. And I believe you can actually do this if you statically imported that method, but I'm just going to do this. And actually one thing I will do is I'm going to rename these methods to be, instead of modifiers with rarity, just modifiers rarity and modifiers count, just to keep it simpler and shorter, which is nice. Okay, the next thing that we can do is the actual datagen. So for this, we're going to create a new package inside of our main package, and we're going to go data dot, and this time it will be dot generator instead of provider. Now inside of here we are going to create a new class, and I'm going to call this tutorial mod world generator. So once again, that'll just be your mod name and then world generator. Now this is going to extend Fabric dynamic registry provider, and we're just going to implement these methods, And then we're also going to add the constructor as well. Make sure that is public constructor. We can provide the name in here. So I'm just going to call this world generator. And then inside of the configure method, we can actually configure it. So we can say entries.add all registries, and we're going to get wrapper or throw. And we're just going to pass in the registry key that we want to use. So configured feature for that one. And then we're going to do the exact same thing for the placed feature. So we're going to do registries.getWrapper or throw registry keys dot placed feature. And that is all we need for the data generator there. So let's come into our data generator class and let's add that as a provider. So we're going to do pack.addProvider tutorial mod world generator like that. And then the final thing we need to do is we need to override the build registry method. Inside of here, we actually need to call our bootstrap methods, but we don't want to call them directly since we only want to call them when they're actually needed. So what we're going to do is we're going to say registry builder. We're going to add a registry. So we're going to add to the configured feature one first. And what we're going to add is configured feature init : bootstrap. And then we're going to do the exact same thing for registry keys dot placed feature. We're going to do placed feature init : bootstrap. Now that will work. That will create our features, and the features will be registered in the game. However, they will not be added to any specific biomes or dimensions since we haven't supplied where they should be generated yet. So let's go ahead and do that. So to actually get them in the world, we're going to create a new class inside of our world gen. And I'm going to call this the Biome Modification init. So what this class will do is it will define how it should modify the biomes to add these features. So we're going to create a public static void, and I'm going to call this method init like that. You can also call it load. Actually, for consistency, since I think in the main class, yeah. So we're actually going to call this load. And what we're going to do in here is Biome Modifications. We're going to add a feature. Now we're going to add this at a specific selector, a biome selector. So we're going to use biome selectors, and we're going to use found in overworld for the overworld one. However, you can also specify a tag. So you can use like biome tags dot, and you'll see there's all these different biome tags, or alternatively you can create your own biome tag, of course. So maybe you only want it in deep oceans, for example, then you can use that. You can also say with an exclusion like that, you can give an inclusion. You can say biomes that spawn specific entity types, and you can just say vanilla biomes as well. So those are all the ones there. We're just going to use found in overworld since that will just make it so much easier to actually find it. And then afterwards, obviously you could narrow it down if you wanted, but we're just going to do that. Then we're going to say generation step dot feature, and this will be the underground ores feature. Is going to be the specific generation step that we want to use. That you'll see there are other steps, and we'll use some of these in future tutorials such as trees. But for now, we're just going to use underground ores. And then we're going to use our placed feature. So placed feature init. And we're going to say overworld example or key. Then I'm going to just copy paste this. Now all we need to do inside of our main class is after we init the other stuff, we're going to do biome modification init dot load. Now, since we have modified the data generators, we need to go ahead and actually run data. So you should have that up here in your run configurations. If you do not, you can always go into your Gradle tab on the right side, and you can come down to run datagen down there. So you can use that as well. I'm just going to run this datagen that I have up here since that will work fine. And we should see after this does its stuff that it will modify our generated package to add those in there. So let's just look to see when it changes. So you see it's written 6 files, and inside of WorldGen, you've got configured feature, which is your configured features. And then you have the placed feature as well inside of here. Now, I will just say, if you were intending to do it by hand, there is actually a very handy website that you can use, which I have talked about previously, which is Miso, linked in the description of all these tutorials. But from here, you can easily choose to generate one of these JSON files without using datagen. So you can go like place feature, and you'll see all of the different modifiers that you could add to it, which is super handy if you wanted to do it by hand or if you wanted to do it for a data pack. Just make sure you're choosing 1.21, not 1.20, since it probably is slightly different. So just make sure that you are doing it for 1.21. And that should be it. So let's go ahead and run the Minecraft client. Now we're going to need to create a new world since we have modified the world gen. So let's go creative. If you didn't want to create a new world, you can obviously just like teleport yourself like 10,000 blocks away or whatever, and you should be fine too. So here we are, we're in a new world, and boom, there it is. So that was actually very quick there. So that is in the overworld, and you can obviously test deep slate as well. Now I did try to look for deep slate earlier, and it took me quite a while to actually find the deep slate one. And there you go. We actually have found it in deep slate. So deep slate is actually a little bit harder to find for me because mine is purple, so it's obviously harder to find. And I didn't actually try and use night vision earlier, to be fair. But you see that is generating perfectly fine. So let's now go into the nether. And actually we found it straight away. So that was nice and quick. Okay, so then let's go into the end. And hopefully we should be able to find it relatively quick here too. There you go. So we found it in the end as well. Great. So in the next tutorial, we will go ahead and do recipes. So we can now do a smelting recipe for these ores, is effectively why I decided to do this one first. And we'll do crafting recipes, so that'll be both shaped and shapeless. And that will be using datagen as well. So yeah, obviously I hope you found this tutorial useful. If you did, please do be sure to give it a like and subscribe. If you have any problems, then my Discord server is always linked in the description. And if you'd like to help support me continue making these tutorials, you can join my Patreon as well. And yeah, I will see you in the next tutorial. Goodbye.